Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 46, permutation. For listing all permutations, we will use Steinhaus-Johnson-Trotter algorithm. The core concept of this algorithm, also known as plain changes, is each two adjacent permutations in the resulting sequence differ by swapping two adjacent permuted elements. Now let's check this algorithm step by step and see it in action. Given an array of non-duplicated integers sorted by ascending order, which is each integer associated with direction. The mobile integer is the integer that is greater than the adjacent integer it is pointed to. And if there is no integer the number pointed to, it's not a mobile integer. For example, if we got a sequence of left 1, left 2, and left 3. 2 and 3 are the mobile integers. Because they are greater than adjacent, they are pointing numbers. Okay, with this, let's follow the flows of the algorithm. First, find the largest mobile integer and swap it with its adjacent integer which it is pointed to. Second, for the all integer that is greater than the largest mobile integer, reverse the direction. And third, repeat this process until there is no mobile integer. For example, consider the sequence of integers 1, 2, and 3. Check max mobile 3. Swap. There are no greater integers than max mobile 3. Next, check max mobile 3. Swap. There are no greater integers than max mobile 3. Check max mobile 2. Swap. Reverse the direction of integers that are greater than max mobile 2. Next, check max mobile 3. Swap. There are no greater integers than max mobile 3. Next, check max mobile 3. Swap. There are no greater integers than max mobile 3. Next, there's no mobile. The formula for permutation of an object is n factorial. Before we jump into the code, let's briefly talk about the implementation strategy. If we got a clear strategy on how to solve the problem, the best way to implement the code is to stick to the plan. I mean, minimize the gap between strategy and the programming language's syntax as much as possible. In this case, we are going to use the integer array to represent a sequence of integers. And about each integer's direction, instead of putting the left or right symbol into an array, we are going to put a higher order function into an array that pairs with the given array, the increment-decrement function. Because eventually, what direction does is point to the associate integer's adjacent index. Okay, we got the implementation strategy. Now let's get to the code. For implementing Steinhaus-Johnson-Trotter algorithm, let's set some basic ingredient. One is a sorted array of integers. And the other is an array of the same size containing operators. Plus, we need a list of all possible permutations for return. Before we implement further, let's implement helper functions to represent each step. And about the helper function, we are going to implement Kotlin extension function for the smoother function pipelining. As the first step of the algorithm, we are going to implement the getLargestMobile function. The core idea is that looping through each integer in the array, find the largest integer that is greater than its adjacent integer. To find the adjacent integer's position, we will get corresponding operator from the operators array and invoke with corresponding integer's position. And since the algorithm needs to be stopped when the largest mobile number is no longer exist, if the largest mobile number exists, this function returns each index of the largest mobile integer and its adjacent integer. Otherwise, it returns null. The second step is swapping. Using the largest mobile and adjacent integers indices, we will swap the position of the largest mobile number with its adjacent numbers. Just keep in mind that when we are swapping the largest integer, we also need to swap its directions, position too. The final step is to switch directions. After the swapping, if there is any integer larger than the current largest integer, we need to switch the direction of all of them. If we made it this far, just align the functions together completes the algorithm. So back to the main function. Find the largest mobile integer and append the current permutation to the return list before swapping it. Swap the largest mobile integer with its adjacent integer. And after that, if there is any integer larger than the current largest mobile integer, change the direction of the corresponding integers. We will repeat these steps until the mobile integer no longer exists. Let's run the code. That's it. For problem solving, introducing and implementing various algorithms is not only meaningful but also intriguing. Even though it's not applicable to a non-sorted duplicate integer array, one advantage of Steinhaus-Johnson-Trotter method is that the small amount of changes from one permutation to the next allows the method to be implemented in constant time per permutation. Hey, by the way, are you curious about another algorithm shouted by one computer scientist as the most effective, fastest algorithm of generating permutations?